California lass.
I'm Germanium Girl.
I am Announcer Man, and today we will be talking to you about the almighty power of gas laws. Give me a P.
P.
Give me a V.
V.
Give me an equals.
Equals.
Give me an N.
N.
Give me an R.
R.
Give me a T.
T.
What does it spell?
Nerd.
Mr. Andy's Exploratorium with Germanium Girl. What is a gas? Let's head over to Germanium Girl for the answer.
Thanks, Announcer Man. A gas is a form of matter that takes the shape of the container it is in. They are characterized by fast-moving particles so small we can't even see them. Gas is spelled G-A-S. And Mr. Andy, whose Exploratorium we are in, hates it if you spell this wrong. Or gases. Or bus. So please, do not misspell these words, or else you will receive an F.
Well said, Germanium Girl. Why are gases important?
Well, Announcer Man, I suppose the gas is important for a variety of reasons. I mean, without them, we couldn't breathe, and a lot of machines wouldn't work.
I am California lass, and I find your lack of general knowledge on the subject of gases to be laughable at best. Haha, see, laughable. You completely forgot to mention that gases are important because they are the highest energy form of matter prior to plasma.
Yeah, because that's so important. Not...
Girls, please. You can prove your scientific superiority over the other in our next exploratorium question. What are the different types of gases?
Oh, I totally know this one. Most gases are colorless.
The ideal gases, or noble gases, are the most stable of all atoms.
A lot of gases form a bond to itself, like hydrogen.
Hydrogen.
Hydrogen. Hydrogen.
Hydrogen.
Funny you should mention hydrogen. Why don't we talk about it for a bit?
Oh, that's simple to the utmost degree. Hydrogen has one electron and one proton, and forms a bond like so. Now clearly, Californian lass can't answer that question because she doesn't know hydrogen is colorless and odorless.
Germanium Girl isn't aware that hydrogen is non-poisonous and tasteless.
She doesn't know hydrogen combines with oxygen to form water.
Well, she doesn't know the ratio between hydrogen and oxygen is 2 to 1.
She doesn't know the applications of hydrogen include being added to nitrogen
To produce fertilizer for soil. I did too know that.
Hold me back, Dad! Hold me back!
Girls, let's go back to noble gases. Can you name them?
There's helium and neon.
Argon, krypton, and xenon.
And radon.
And what other important gases are there?
Where would we be if we didn't have oxygen? Clearly the most important of all gases. It is vital to our survival. Atomic number 8, atomic mass of 15.9994, desiring a cation which has a charge of positive 2 and known for having 2 self-bonding electron pairs.
Oh, please, Californian lass. You're forgetting nitrogen? Atomic number 7, atomic mass of 14.0067. It wants a positive 3 for its cations, and it forms ammonia, among other things. Nitrogen is so much more important because plants need it, despite it being a gas.
Want to see a magic trick? It's quite simple. All you need is a nice Erlenmeyer flask, a little piece of paper, a match, and a hard-boiled egg. Where could I ever find a hard-boiled egg? Oh, thank you. Alright, so what we're going to do here is we're going to light this piece of paper on fire. We're going to place it in this Erlenmeyer flask, and we're going to quickly put this peeled hard-boiled egg on top. Voila! That was good. So this is what you just saw in the experiment. We had our Erlenmeyer flask, and we lit the piece of paper on fire and stuck it in the Erlenmeyer flask. Then quickly put the peeled hard-boiled egg on top. And as soon as the fire went out in the Erlenmeyer flask, the temperature decreased. It therefore created a vacuum, and the egg was sucked into the Erlenmeyer flask.
That was nowhere near as loud and explosive as our viewers want. Let's try something more awesome, like this. I've got an empty can, right? And I put just a little bit of water into it and put the can over a heating element. I let the water crackle and pop inside the can and quickly flip the can into the bath of ice water. That was one crushed can. This is Gay-Lussac's law. Pressure is directly proportional to temperature if volume and moles are being held constant. Now let's go over to Announcer Man to explain the previous experiment.
Thank you, Californian Lass. Now, what happened in the experiment is very simple. We heated up the can with a little bit of water in it. That increased the pressure. You put that pressure, that hot can, straight into the ice water, BAM! You have yourself one thoroughly destroyed can. Thank you. Hi! Boyle's gas law. Simply stated, as pressure increases, volume decreases. As volume decreases, pressure increases. Now this is vital in such great experiments as putting a peep into a bell jar. Why? Because whenever you suck the pressure out of the jar, the peep expands. If you've never seen this, I advise you look it up on YouTube.
I am the great and powerful Mr. Andy, and you have defiled my exploratorium with your silly dabbling. Behold, Pivner.
But what does it do?
It kind of looks ugly.
No! You can determine any of the variables in here as long as you possess the variables you are not looking for. Have pressure and temperature and moles. You can find volume. Volume, moles, and temperature. Pressure is to be found.
Okay, Mr. Powerful, but what applications can be found in this in today's world?
Yeah, it's not much use if you don't know why it's vital to know.
Tisk, tisk, you poor misguided elements. In reality, the combustion engine, the most useful of all the modern tools today, is made possible by Pivner. Respect the universal gas law. Respect it!
I'll say this then.
Hold on.
Put a peeled hard-boiled egg on top. Want to see a magic trick? It's quite simple. All you have to do is take a piece of paper, light it with a match, place it in this glass jar we have. Oh gosh!
Throw it in the sink, throw it in the sink. Throw it in the sink.
Oh, it's burning my hair!
Okay?
Put a peeled hard-boiled egg over it.
No, the ration between hydrogen and oxygen is 2-to-1.
Great and powerful Mr. Andy, and you have defiled my exploratorium with your silly dabbling. Clearly,
Gases form a bond to itself, like hydrogen.
Funny you should mention hydrogen.
We already did this part, though.
Yeah. Funny you mention.